Once again, Assalamu alaikum everyone. So, in the previous session, I hope that you have seen the recordings of NumPy, the people who are not present here. So, basically, what we did in that is we just saw how to create NumPy arrays and what are the functionalities that are provided by NumPy arrays. So, I also discussed very important thing, that is why are we using these NumPy arrays, because everything that we have in our computer is basically made up of numbers, and whenever we read these numbers and we have to manipulate them in some way. I see people leaving and joining. Is my screen perfectly visible? Okay. So today we'll be learning about pandas. So this is again a library. Okay. Can somebody tell me what is a module? कोई बता सकता है कि मॉड्यूल क्या होता है? मे बी उमर, व्हाट इज अ मॉड्यूल? पिछले जब नंपाई से पहले हमने डिस्कस किया था ये, व्हाट इज अ मॉड्यूल? उमर, आर यू देयर? So do you know what is a module? Do you remember? Okay. Okay, nice. So you at least have a rough idea. I think like this is like fair enough definition of a module. Module is some bunch of code, and when we put these functions together, तो एक module बनता है. उन modules के मिलने से एक library बनती है. So today we'll be discussing about pandas. This is really important library, and I think you'll be heavily using it whenever you are doing some projects. So you'll be using it. So what is this pandas? So pandas, it provides us various data structures. As NumPy, we had that ND array. That NumPy provides us these ND arrays, and we can manipulate data in these ND arrays. So in the similar fashion, we have some data structures which are provided by these pandas, and then it makes this manipulation and the analysis of the data very easy. Okay. So it also handles, for example, tabular data. Data is of different types. So let's write here data. So there are a lot of types of data. So if you see, there is a tabular data. So what is the meaning of tabular data? Is that we have tables like this. For example, there are columns and then there are rows. We call it a tabular data. Okay. Then we have, for example, a data which we can categorize, let's suppose, as textual data. Textual data. Okay. For example, this data right now which I have written on this notebook, it basically is a textual data because it consists of text. Then we have, let's suppose, audios. This basically, there's also data. So based on these things, so we have to analyze different sorts of data. तो अगर हमें कोई भी machine learning model बनाना है, तो the first prerequisite is that we must have some data. So data के different forms होते हैं, तो उस data को manipulate करना पड़ता है. So we have to manipulate the data, and for that, pandas is really helpful. So first, it will help in handling the tabular data that I have written here. So for example, if you have SQL, because SQL stores what's called as a relational database, if you know. So अगर तुम्हारे पास Excel spreadsheets है या SQL में data है, तो it becomes really easy for us to manipulate and access the data by using pandas. Then it also handles heterogeneously typed columns. That means, for example, if a column has some integer values, for let's speak about data. So we have this table of data. तो इसमें हमारे पास क्या क्या हो सकता है? So let's suppose we have address. तो address में हमारे पास कभी numbers हो सकते हैं. Then we can have strings as well and things like that. So ये चीज़ बहुत easily access और बहुत easily manipulate कर सकते हैं हम pandas की मदद से. Then we have time series operations. So again, a type of data. So what is time series data? So if something is dependent on the previous timestamp, for example, let's take the example of weather. कल कैसा weather था? Probably it has an impact कि आज कैसा weather होगा. Let's take an example of stock market. तो स्टॉक मार्केट में आज किस कंपनी का कैसा स्टॉक प्राइस था, वो डिपेंड करता है कि पिछले बार का कैसा प्राइस था. एंड देन इफ़ यू सी दीज वेबसाइट्स लाइक अमेजॉन एंड डेटा, उनका सेल्स कैसा था. फॉर लेट्स सपोज आइसक्रीम सेल्स. So ice cream sales will be high when there is summer. So this data is called time series data. Like basically, in nutshell, I'll say informally we'll say that time series is a data which has something to do with time. Okay. Then we can also handle matrix like data. For example, we have these ND arrays which are provided by NumPy. So we can manipulate these things by using pandas. Okay. Panda basically what it does is it provides us basically two main data structures. There are only two main data structures if you remember them. The first one is called series. Okay, so I'll just highlight them. First one is called series, and then the second one is called data frame. Let's first see what is a series. So if we have been seeing these lists in Python, tuples in Python, similarly in Pandas, a series is a one-dimensional array. Okay, it is just like our list, but it has some additional features. Okay, so it holds a sequence of data elements. For example, it can hold integers, it can hold strings, floats, or Python objects, or anything like that. So each element has a label. Okay, that's called index. सीरीज क्या होती है बेसिकली इट्स अ वन डिमेंशनल डेटा सो वन डिमेंशनल डेटा में हमारे पास कुछ भी हो सकता है वी कैन हैव अ सेट ऑफ इंटीजर्स वी कैन हैव प्रॉब्ली फ्लोट्स वी कैन हैव सम ऑब्जेक्ट्स सो हर एक ऑब्जेक्ट के एसोसिएट एक लेबल होता है जिसको हम लोग इंडेक्स कहते हैं ओके इफ यू सी अ टेबल अगर इस टेबल के एक कॉलम को देखा जाए तो देन वील कॉल इट अ सीरीज ओके सो अगर तुम लोगों ने फॉर एग्जाम्पल इफ यू हैव अ bunch of classmates in your class so you'll write their names you will make a table like this so you will write their roll numbers and then you will write their names okay you'll fill the names right here and then you'll have roll numbers here so roll number serves as an index because this is a label so अगर मैं यहाँ पे अपने क्लास में हम लोग हर एक स्टूडेंट को एक नंबर दें फॉर एग्जाम्पल लेट्स से रोल नंबर 1 is probably like Zahid and then we have Mavish so each of the roll number is associated with a name so similar in series we have data which is associated with a label that is called as index okay then we have a data frame so what data frame is so data frame basically is when we have this collection of these series it makes a data frame okay and just remember this Python is built on top of this NumPy so it has seamless integration with these things for example if you are creating ND arrays in NumPy so in Pandas you can just call one function and then manipulate its data as well so here I have seen why are we using Pandas for example if we have Excel sheets and stuff like that and most of the people I have seen they'll use Excel sheets because it seems easy but when you really get a hang of Python hang of this Pandas library you will hate Excel sheets because you won't be able to do much of the things in there which you are able to do in Pandas so these are some features which I have written so you can just read them when I'll send these notes so I'll just read it out effortless handling of missing data so what is missing data basically if for example you are collecting some data so today we'll be having a great look at how data is collected and what type of data what I mean by data basically so while in the collection of data sometimes there are some missing cells missing values they don't have a value so हमारे पास कुछ patients for let's talk about patients हमारे पास कुछ patients के records है so in which we have for example blood cholesterol levels and then we have ECG and then we have heart rates किसी किसी patient के लिए हमारे पास heart rate नहीं होगा तो that we call as missing value because we have to handle those missing values as well so this Pandas it provides us ability to handle these missing values then we have size flexibility so it allows us to have dynamic modifications of these data frames okay into higher dimensional object that we'll see I think I need not to go in each of the details in this because this is just a theory and I want you to do hands-on as soon as possible okay so these are some features that have been mentioned there in the official documentation so you can just write it read it there it's not a big deal okay let's see how to import Pandas first okay so I'm just writing here an import statement then I'm writing Pandas then as means alias because I'll be using PD like in short form I'll be using PD so I also explained the concept of aliases in some previous session okay so first I'll show you some data and I'll go through the basics first and then we can start so first I told you that there are two main data structures that the Pandas provided the first one is series and the other one is data frame okay so how to import it? Here you have just write this line import Pandas as PD now let's start by creating a series how to create a series so there is a function called as series so PD means this shortcut alias then PD.series and then I'm making a list so if I print it out you can see that it is an indexed list so you can see the 0 1 2 3 4 here you can see that so these are the index corresponding to these elements so and you can also see the data type in here that is int64 if I just go to the coding window and show you that is my coding window visible no okay it is visible nice so here the first cell is import Pandas as PD so I'll run it so now I'm creating a series so I'm also printing it for example let's change this numbers let's also add 6 so that you may see the change So here you can see that we just created a series in which we have numbers from 1 to 6, and then we have this index 0 1 2 3 4 5 6. Okay, the first thing is we can create this series basically from Python lists. As we saw in numpy arrays, we created those numpy arrays also in by using those Python lists. So this is one of the methods. So you can create a list, and then you can just type pd dot series and then give this argument as this list, and then you can print it out, and it will, this thing will be printed. So this is one method. If you have a Python list, then you can directly create it. Then I also told you that there is seamless integration between numpy and these pandas. So if you have a numpy array like this, okay, if you have numpy array, so you also can do the same thing. You just need to give it argument to this pd dot series. तो इससे क्या होगा? So when we had this numpy array, so it will be converted into pandas series. Okay, series, what I mean by series, it is just one column, so it has index. As you can see, we have indices here. Okay, let's go back to the coding window to show these things in action. So for example, list, this is understandable. Let's see, like, is it really the type and the array? So we'll print the type of this. So print type of data array, and then we'll see what is the type of this. Okay, so if you can see on the screen, you can see that class numpy and the arrays. Now I have, this is the code line, pd.series data array. So I'm giving this, and now after this I want to see what is the type of this series from array. So what I'll do is I'll just write print, again the same thing, print, then type, no, print, then I'll write this type of what that I have converted. So you can clearly see that. Then we have this panda.co.series. So this is the class basically which the Python, which this panda series has. So we basically converted a numpy array into a panda series. Okay, let's go back. Then we can also create a series from a dictionary. So you know that dictionary is defined, but you have these curly braces, and then you have key value pairs. Okay, key value pairs. So here the key will serve as indices. So these will, key will be indices, and these value, they will be basically values. So if I have a dictionary like this, so dictionary is, we have Alice 25, Bob 30, Charlie 35, something like this. We have been using this example I think since day one. So this is a dictionary, and then we want to convert it in the Python series. So we'll just write pd.series, then have the dictionary. So when we'll print this, so you can now clearly see that indices are Alice, Bob, and Charlie. So initially what there was, this default indices were 0 1 2 3 4. Okay, so now we are giving this Python series, this dictionary. So in that, the indices basically are the keys. Is this clear? So here we have changed the indices, if you can see. Is it clear? Nice. Now if you want to give custom indices, so by custom indices I want, for example, you want to set roll numbers to the people. You don't want these, for example, these default indices, so you want some custom indices. You can also do that with series. So what you can do is, you will create a data, for example this data, it's a list, and then you want to give custom indices A B C D E like this. So this pd.series, it will then take two arguments. It will take the first, the data, this basically is 10 20 30 40 50. Then it will take this index is equal to custom index. Then if you see, if you print this data, you will see these indices are A B C D and E, and then we have the values over here, if you see it. So let's go back to the coding window to show you it there. So here we have let's suppose custom index we have, for example, if we have 10 50, and let's add one more element 60. So this basically is our data, and the indices that we want to set is, let's say, A B C D E F, and we want to just add F. And if I run it, you can clearly see that we have A B C D E F, and then the corresponding these values are 10 20 30 40 50 and 60. So this is how you can create custom indices in there. Then we have what is called as data frame. So here I'll write, this is a data frame. So what data frame has, so here this is an index column. So we have index column. Then these are our features, or we call them attributes. Attributes. Okay. So basically this much is our data. Okay, so here each row is called a data point. Okay, each column is said as a feature, one feature. So what is a data frame? Is just a bunch of rows and columns. Just you have that in spreadsheet as well. So in there, for example, if I show you the spreadsheet, you might have seen spreadsheet like this where you add name, age, sex, and then you add these indices as well. So similar to this, we have a data frame in our pandas library. So that I have created over here. For example, this is a data frame created by using a dictionary. So I have used a dictionary in here. So in here we have this basically as key, then these are our values. So what will happen is, so corresponding to this key, corresponding to basically this column name, so this will act as a column name, and then these will be the names. This is a list of comma separated list, so these will act as names. Then again age, this basically will act as another feature. So name is one feature, age is another feature, and sex is another feature. And correspond there is a list of elements. So these lists will basically be the value of these columns. And by default we have this index. So data frame basically is, it's a table in which we have a column of indices. So we call this index column. Okay. Then we have a column of, when we have a row of features. Everybody of you, I suppose that you have used Excel, and some or other day you must have used some. For example, for maybe in your classes you have named them and put roll numbers who have done the projects and stuff like that. It basically is like a table. Okay, but what's the creation method? Here we have used a dictionary. If you see it here, so in dictionary we have these key value pairs. The first thing here is, it is a column name. Okay, then we have column age, then we have a column sex, and for each column this is the data. So for each column this is the data for each column. Okay, if I go to the coding window and I show you there. So here what we have basically is a data frame which I discussed. So we are creating a data frame, we are just giving the name, it will basically act as a column name, then these will be the column values. Okay, then we have age, then we have sex. So if you have this one row, I told you that one row is called a data point. So data point, it has a name, it has an age, and it has sex. For example, we have here Brown Mr. Owen Harris, so his age is 22 and he's a male, something like that. So how we can create it? So you can just create a dictionary and then call this pd.data frame function. Okay, so you will, for example, if I want to add maybe some another column, let's suppose I want to add nationality. Okay, so nationality, we are adding that, and this is the key, and then we'll add lists because we have three people. Let's suppose one person is Indian. Okay, let's suppose another person is Russian. Okay, then we have one more person, let's call he's from let's say Canadian. Okay, so if I just run it, so I have just shown you how to add one more column here. So I have created one more column of nationality, then I have given a list of these values, and this will set into columns automatically. You can see that. So you can see that here we have this name, age, sex, and then nationality. So here I am printing this df. If you also want to check what is the type of this, you can just call the function type of df. It will show you that it is a data frame basically. So here I have given the details of this data frame. So it's a two-dimensional structure basically in pandas. So it acts like container of it can take any data type. So it can take data type of integers, strings, or maybe categorical values. We'll discuss more about these things. Is this data frame clear? Data frame, basically each of the column is a series. If you see this data frame, each of this column is basically a series. If I take this is a series. If I take this is a series. Is the concept of data frames clear? So I taught you two things right now. So first thing is we had series as one data structure, and second is we had data frame. Okay, now we are going to manipulate this. If you are clear with this, now we can move forward. So first we'll again see some methods how to create this data frame. The first method we saw, we can use dictionaries. I think this is clear. And then we can create data frame from list of lists. Basically list of list means 2D array sort of thing. So you have this data, so this is a list of list. I told you that you have two concepts to visualize it. First thing, if you have a list like this, and each of the element itself is a list. Okay, something like this. So this is one way to visualize the list of lists. I think I should switch the screen. So I'm saying that the first thing that we have here is list of lists dictionary I think is clear. I showed you how to make a data frame out of dictionary. Then we can also create it from lists of lists. Okay, so list of list, one way to visualize is this way, because each element of the list itself is a list. So then we have some elements in here. Okay, another way is just think it as like a matrix. Okay, so here we have a list, this is a list, and inside the list the elements itself are list. Okay, you can see that here. So if you have a list of lists, for example, Alice 25, male, Bob, like similar to the dictionary we have, and then let's create a columns list again. This again is a list. Okay, then we want to create a data frame out of this data. So we'll just write pd dot data frame, then give the data. This is our data that will go into these cells, and what should be the columns? We'll write columns is equal to column. So this is what will get printed. Similar to what we had previously when we had dictionary. In that we had key value pairs, but here we made a separate list of columns, and indices by default is 0, 1, 2, 3, 0, 1, 2. Okay, the first method was how to create a data frame is by using the dictionary, and second method is list of lists. What is the one major difference? So in dictionary, these key values which we have, these keys, they act as column names, but here we have to explicitly give column names. Explicitly give column names. Is this clear? Is the difference between how to create a data frame from dictionary and how to create a data frame from list of list clear? Is it clear? Nice. So then you can also create an empty data frame and add data later. For example, I can just call this pd.data_frame. So what will happen is it will create an empty data frame. So after that you can just keep on adding these columns, and so this is our column first, then column second, column third, and then we can add the data in the columns. So this is another way. Okay, so one way was dictionary, second was list of lists, third way was that we'll create an empty data frame. Empty data frame, df, let's write it, and then add the data. So as you can see here, I created a data frame df initially, which was empty. Then what I did is I added these columns separately. So df name, then Alice, Bob, Charlie, df age 25, 30, 35, ds sex, female, male, male, something like. If you see, you'll get this on the screen. Okay, then again you can create data frame from numpy arrays. So if you have a numpy array, let's generate a numpy array, because in the previous session we saw how to create a random numpy array. So np.random.rand 3, 4. Basically what will happen is it will create a 3 by 4 numpy array. So we store that in data. So now we'll send this data to this data frame, and then we'll also add columns, because we have 4 of these columns, 1, 2, 3, and 4. So we'll name them as A, B, C, D. Okay, so here if you print this, so this is what will get printed. Is this clear? There are many ways. I'm just showing you a few ways. For first we showed you how to create it from dictionary, and then we showed how to create it from list of lists. Then we showed it how to create an empty data frame first, and then add data into that. And another way is that we have numpy arrays, and out of these numpy arrays we can create these data frames. Okay, most of the times you'll be using data frames. I think you won't use series much, but you will be using mostly these data frames. That's why I want you to show how to create data frame. If you have some data, for example, written on some files, and you want to create that into a data frame, this is the procedure basically. And let's go into the index. Okay, by default you saw that we have the index 0, 1, 2, 3. I also showed you how to create custom indexes. So in that you should give this argument as index custom index. Okay, let's go to the coding window and show you this, how to create custom indexes. Okay, is my screen visible? Just give some thumbs up. Yes, nice. So for example here, let's have this. So in here, if you see that we created this pd.data frame in here. In this example we had A, B, C, D, and the index by default was 0, 1, 2. So if I want to create index, like I want to have custom index, so let's suppose I'll create a list of index, and then I'll name the index as, let's suppose, A, B, C, D, or something. Let's give them names. Let's say Umar, and then we'll have, say, Zubair, because we have how many data points? 3 data points, so we must give 3 names. Let's suppose we have Zubair, and then let's suppose we have Amir. Okay, so this is our custom index. So we want, instead of this 0, 1, 2, 3, 0, 1, 2, we want these names should appear there. So what I'll write is, I'll just add one more argument here. So I'll write an argument of index. That's why understanding of these functions is necessary, because data frame basically is a function. So first argument we gave is data. The second argument we gave basically is columns. The third argument we are giving is index. So I'll put index is equal to index. So if you remember, this is called as keyworded arguments. If you remember this. So now if I'll print this, now you can see instead of the 0, 1, 2, you will have your names on the data frame. So you can see that. Is it visible? You have this Umar, Zubair, Amir on this index. Nice. So this is how we create customized indices. Okay. There are a lot more ways to create. We can set these indices afterwards, and then let's suppose we want to reset indices. For example, you had these indices like this, so you created some custom indices. Now you want to have this indexes, you want to have it as a column. Okay, you want to have it as a column, and then you want to reset basically, and you want the default indices like 0, 1, 2, and so on. But the indexes you create, you won't have that as a column. So suppose right now I created a custom index in which I put your names. So but instead of name, now I'm saying that I want to add that name as a column, that index basically, and I want to reset the indices. I want to have indices as 0, 1, 2, 3 again. So what I'll do is, let's go back to the coding window and show you there. So here you can clearly see that we have this. So for this we have a function called as reset function. Okay, I'll just write df reset. So I'll just create a data frame, new data frame. So in here I'll just write the previous data frame df dot reset. Okay, so here I'll write reset, and then I'll write reset index. So this is the function we have to call, and it will basically reset the index. If I print it again, so you can clearly see that. No, I need to print this df reset. I don't need to print this df. So what I'll do is I'll print this one now, because this is what I have resetted. So if I print now, you can see that we have a new column, index column, but it was added as a column now. So indices here got reset. We have this 0, 1, 2 as indexes, and this got added as a separate column. Okay, our indexes, that the custom indexes got added as a separate column, and we had this default indices, that 0, 1, 2, 3, by using this df.reset index. Is this clear how to reset indexes? And if you have custom and you want to add that as a column, is it clear? Okay. So then we have also what is called as hierarchical indexing. Okay, what is that? It's sometimes called as multi-index. So for example, you want to have an index like this. So sometimes you want to group things together. So for one group you want to have an index. Suppose तुम्हारे पास दो groups है. Let's have a group of boys and group of girls. So here we have girls, and we don't want to indice each of the boy. For example, we have Zubair, we have Amir, we have Jahangir. So we don't want to indice each of the boys, but I want to indice them together. For example, I have a group, I can index them, let's suppose, with boys, and then I have a group I'll not write, for example, Mehvi, Sharika, and then we have other girls as well. So in that I will not indice each of the girls, I want to index the group as a whole. So this is called as multi-index or hierarchical indexing. So for example, sometimes you have different categories of things. So sometimes if you go on a shop, so you are creating a database for shop. So in that you have soaps, and you want to label soaps as only soaps. And then you have some, let's suppose, some stationery, you'll label that as a stationery. So you don't want to name each stationery. In stationery we have pen, copies, markers, and things like that. You don't want to label each the thing. You want to label the group of items. So that's where the concept of hierarchical indexing comes in. So for that, how do we do it? It's like this. For example, here we are creating the data, basically the data frame. Here is a dictionary. So then how to create this multi-index? So multi-level index will be created by giving this list with, we will give these tuples within the list. So for example, we have group A, group B. Let's suppose group A is of boys and group B is of girls. So we'll say that group A, this index, like for example, in the previous example, if you see that we created indices as well, id 001, id 002, id 003. So what I want to do is that I want to say that id 001, id 002, these two things are in group A. Okay, and id 003 and id 004, they are in group B. Similar to, for example, if we have your examples, instead of this id, I'll have your names. I'll say Amir and Jahangir, Zubair, Rian. All of these people are boys, so I'll just index them as boys. Okay, and for the other people who are girls, so I'll just group them as girls. So if I now create, we have this pd.data frame, then we'll give data. Okay, then in the index where we were just giving the index, here we'll write pd.multi-index from tuples. Okay, then we'll give this multi-index and the names of these. Then if you see, you can clearly see how this got grouped. So group A we have here. So there are two people in group A, and then group B. So there are all again two people in here. So is the concept of multi indices clear? Multi indices. This is how basically we create multi indices. So you will find a lot of applications. I just told you, if you are creating database, let's suppose for pharmaceutical company. So there you will have indices. Let's suppose generic medicines, for example, medicines for this disease, medicine for that disease. There will be a lot of medicines in that, but you want to group them together and name them and index them. You don't want to index each of these things. So for that we'll use multi index. So how to use multi index is basically we'll use tuples within the list, and then we have in this index we'll call this function multi index from tuples. Okay. The other thing is, which is really important, is how to read files, because data mostly will be given in the files. Okay. And the most famous format is CSV format. Okay. CSV means comma separated, I think list or something. Okay, you can just see the full form. So these are comma separated lists. So in that, let me show you the data first, and then probably you will understand. So here I'll show you a data set which is of the heart patients. By heart patients I mean these patients had heart diseases. Okay. I think back 1 month ago I worked on this data, that's why I want to show it. So this data set basically has 15, I think, features. It has 15 features, and we had a bunch of 297 patients. So we have, it is stored as a CSV. You can also open it in Excel. You can just have your Excel and open the data sheet. It will look like this. This is your data. So here, but there are more values. There are 297 values. So each of these is a patient. So we don't have the name of patients here. So there is an attribute or feature of age, sex, and then I think this CP. It has something to. This is cholesterol level. I think I can also have that list with me where I have the details of these things. So these features basically are related to medical. For this is rest ECG. Then we have this rest blood pressure levels. Then we have this slope and CH. Basically, these are the test reports, you can say. Test reports for each of the patients. Sex 1 means basically male, 0 means female, and age is 69, 66, 65, something like that. And then you have this blood pressure. If you know that the normal blood pressure is between 90 by 60, if I'm correct, to 120 by 90, something like this. Is called systole, diastole blood pressure. So here we have collected, I think, the systole blood pressure. So you can see the blood pressure levels here. If somebody is from above 140, so that is called as he has hyper blood pressure, or we call it high blood pressure. Then we have low blood pressure who is less than 90. So in this list, basically in this. So we had this data, and the task at our hand was to predict whether the patient will have is cancerous or not. Is cancer. So we want to see कि patient को cancer है कि नहीं, just by looking at the data. We don't want to see the ECGs and things like that. We want to see these features which are just calculated by machines, and we don't want to go to these MRI scans or have some other sophisticated technology. We just had these data which can be easily collected. So you can just have these, like, check cholesterol level, check this resting ECG, then see what is the blood pressure, and then have what is the blood sugar levels. And by using this data, we wanted to see if a patient is cancerous. Is the problem clear? Is the data clear? First, tell me this. Okay, so everybody, the data is clear that you know the task at hand was this condition. Condition 0 means the patient does not have a cancer, and 1 means it has cancer. The first step in everything, we have to read this data now. So we cannot read this data by using Excel and then apply algorithms. For that, we must use Pandas. Like, there are other libraries, but Pandas is the most famous library. So in order to implement any algorithm for this, for example, if I wanted to implement supervised support vector machines, if I want to apply neural networks on this data, the first thing is I have to read this data. Okay, so Pandas provides me with a function known as read CSV. So this is read CSV, a function. So here I have given the path. If you see, this is called the path. So this read CSV will take the path of the file, so it will read the file first. Oh, now you can manipulate the file. So if you have this in Excel, so you can just have limited manipulations. You can maybe plot some graphs or do some stuff with Excel. But if you want to train some machine learning models or train some other models or do something with the data, so for that you must have access to the data. So by reading files, we have uh, way more many methods of reading files, and there are a lot of types of files which Pandas can read. Here I am showing you how to read a CSV file and how to do the things with CSV. Okay, so the first thing is this is a this function read CSV is a function in which we'll give a path By path, I mean the location where your file is stored. So my file is stored at home, Musawwir, and then I have number, desktop, datasets, and this is dataset name.csv. The path basically can be of two types. It can be absolute path, or it can be a relative path. What is the meaning of absolute path? Absolute path means that you are giving the whole information about the path. So for example, in your disk there is a home folder and you are telling everything. Okay, so this is called absolute path, where you do not take for granted things. So in relative path, what we have is, if you have a file stored somewhere, if I am writing this code, for example, on this desktop, so I'll just write dot slash then datasets. I'll write half of this. Okay, this is just informal definition of what is meaning of the relative path, and we can go into the details of operating systems to understand what is the meaning of absolute path, relative path, how these hierarchies work. So it will basically digress the discussion. I just want you to remember that absolute path is a path where you give the full path name. Path name basically a location that the file stores. And for example, here I stored with home, then my name, then desktop, then datasets, then hard cleavage upload.csv. This was the whole. This basically is absolute path. So relative path means absolute path. So relative path means if I am using my machine and I am giving, for example, only this much a path, and I assume that my machine will be able to figure out from this, because maybe my file resides in the same folder. I'll just write dot slash and then I'll write something. Is the concept of relative path and absolute path clear? Okay. Nice. Why am I telling this? Because most of the times you will be using relative path or relative path for your files, and but I prefer to use absolute paths for the tutorial purposes, because I don't want to have surprises, because otherwise I can't find my files. Okay, so this is the way I'll read the file. I'll write this read CSV, and then I'll write the path name, and maybe it can be absolute or relative. So then I am storing it into a variable that is data. Okay, if I want to print the data first, let's go to the coding window and show you that. Okay, so we'll go to the coding window. I think this data frame creation is clear now. Now we are on the reading files. So here I have read this data. Now I want to print it. So I can just print data. So you can see this is the data printed. Okay. So if I want to see the shape of data, basically by shape I mean how many rows are there, how many columns are there. Each row is a data point. Each column is an attribute. I want to see that. I can just, there's an attribute called shape. I think I have also discussed in the NumPy lecture. So we'll just call this attribute shape. It's not a function, remember, it's a shape, it's an attribute, it's not a function. Function is basically we have these two braces after we call the function. So data.shape, so you can clearly see that 297 cross 14. That means we have 297 data points and 14 features. 297 patients basically. We have recorded there 14 features. We have recorded there 14 attributes, or we have conducted there 14 tests or something like that. Okay, this shape will be really helpful, because for you have a huge file and you want to see how many data points are there. You can just call shape. Okay, and you want to see how many features does it have. You can just call this shape, and then you will find how many rows are there, basically how many data points are there, and how many columns are there, how many features are there. Okay, then if you do not want to see whole of the file, and then you basically want to see only few of these data points, how they look like, you can just call this data.head. So what will it show? It will basically show you the first 5 data points in the file. So you can see that we have first 5 data points in the file that we have. So here we write it, the first 5. There's data.head. Then we have data.tail as well. If you want to see the last 5 points, so you can write data.tail. So here we have, these are the last 5 points. So head basically is used to show us the first 5 data points, and tail is used to show us the last 5 data points in the file. So this is the first step in creating any machine learning algorithm. So first you have to see the data, you have to analyze it, you have to read the data, and you must understand the. And I want to digress a little bit here to give you the perspective, a context. So why are we using these things? देखो यहाँ पे मैं I have very little knowledge of biology, okay, but I want to train a machine learning algorithm which detects diseases. So my thing is, so where should I learn this? मैं मुझे ये features समझाए. So that's what is called as domain knowledge. Domain knowledge. Remember this. So having a domain knowledge is a plus point. Okay, because here we are computer science students, maybe we are not domain experts. So in there, I don't know what these attributes mean basically. So I'll go to a doctor, or probably some people who are experts in medical. So I'll ask them, okay, what are the features? What are these features? Do you even think that these features do impact cancer? So for example, I'll say them, क्या तुम्हें लगता है कि कोलेस्ट्रॉल लेवल कम या ज़्यादा होने से कैंसर पे कोई इफेक्ट होता है? अगर किसी का कोलेस्ट्रॉल लेवल बहुत हाई है तो डज ही हैव अ चांस ऑफ कैंसर? सो डोमेन एक्सपर्ट्स विल टेल मी about these features, ki which features to collect. I hope that features is clear to you. Features basically means what are the things about the data point. So these features, like whom do we consult? Basically, domain experts. Domain experts. So when you are right now, for example, we are making algorithm which predict cancer. So मैं खुद तो ये करूँगा नहीं, because otherwise I'll have to read whole the biology. So it'll probably take me another 3 4 years to understand all the cancer things. So it's better to have a domain expert in the team which understands data well, so that he can make you understand the data. कि for example I'll show you like right here कि वो ऐसा बोल सकता है कि cholesterol level, look, if there is a high cholesterol level, probably high cholesterol level is somewhat related to cancer. इससे क्या होगा, कैंसर के chances बढ़ते हैं. So these features are somewhat related to having cancer also. So this is the job of domain experts. So even we have a phase of data collection that we skipped. So we assume here that we do not collect data because data will be readily available to us. So even some people are there who will collect data as well. So for example, अगर किसी को ये problem solve करें, in I think when we will solve our first machine learning assignment, there I'll also tell you to collect data. So data collection से start होता है कोई भी algorithm. So डेटा कलेक्शन करेंगे, उसके बाद हम लोग ये आएंगे कि डेटा रीड कैसे करते हैं इन चीज़ों के लिए. सो फॉर दैट आई एम सेइंग यू वी हैव डोमेन एक्सपर्ट्स इन द फील्ड एंड यू मस्ट हैव डोमेन experts within you, within your range, who will understand the data and they'll explain it to you. Otherwise, like, how can we create a machine learning algorithm without understanding the data itself? The first step is that domain expertise is a plus point, but it is not required. Why is it not required? Because then you will have to read all the domains that exist in the world, क्योंकि machine learning कहाँ use नहीं हो रही. We use machine learning in mechanical engineering, we use machine learning in medical sciences, we use machine learning in astronomy, we use machine learning in cosmology. Every subject that exists there, we apply machine learning in there, because we have data and we use machine learning there. So for that we have domain experts who will make the data understandable so that we can create the model out of that. Is this clear? Like, why do we need domain experts in our field? Because I can be an expert in, for example, computer science. Computer science is just a tool to solve problems. So for that, if I want to understand a problem well, so for that I need domain experts. अगर मुझे for example astronomy की कोई problem solve करनी है, and for that I need to know what are pulsars, what are these stars, what is a hypernova, what is a supernova, and things like that. If I want to solve a problem related to biology, for example, let's suppose right now we have this medical case. I need to know कि for example fasting sugar level क्या होता है, cholesterol level क्या होता है, and then what are the other things that are related there. So for that domain experts will be there, and then they'll make you understand the data basically. Now you have the data. So we are in the first step of our machine learning. We are reading the data first because we want to understand कि मैं read कैसे करूँ, then I'll manipulate the data basically. Okay, so for that I showed you there is a function head. If you want to just see, have a glimpse of the data कि मुझे पहले 5 पॉइंट देखने कैसे दिखते हैं. So for that you will have to look at the data. You'll just call this head, and if you want to see last 5 points, then you can just call data.tail. Okay, you can even, I think, give arguments in here. If you want to see less or more points in here, so you can just give, let's suppose, head of 3 only. Okay, I can give head of 3. You can see that it only gave me 3 points. Okay, you can even give head of, let's suppose, 10 points. It will give me 10 points if you see it. So by default it takes 5 points. So you can also, like, if you want to analyze data more, you can just play with this head and tail method. Tail basically shows the last points and head shows the initial points, initial data points. Okay, so I read it. So now you can see that by default there is an index 0 1 2 3, something like this. But if I don't want this index, if I want, for example, this age should be my index or something like that, I'll write index column is equal to 0. That means the 0th column is my index now. So if you see it here, so here you have had this 0 1 2 3 4. This was our default index. But what I want is, I want an index, for example, a column from here that should serve as index. I'll write this additional function, index column dot 0. I think there are 40 plus parameters in this read CSV function. I don't know exactly how many, but you can just read the documentation. Here I'm saying there are some additional features, like here index column is 0. I'm saying that take this age and make it as an index. So I'll just run this cell and you can clearly see that now the index is this age. Okay, then this is the index file now. 69, 69 and 60, this is the index. Okay, I showed you how to view this data by using head and tail, and now let's again see what are the indices. Okay, so by indices I mean these values that we showed. These are the indices. If I want to see them, if I want to see कि कौन कौन सा index है इसमें, So I'll just call a function that is data.index. So what it'll give me a list as output where it will give me the indexes. So as you know that I just changed the indexes, I changed the indexes to the age. So if I call this data.index, so it will give me a list of indices which will be having the values of this index. Okay, because having the index is really handy for, because you want to, for example, find something, you can just write 35 and just get the whole row out of that. But sometimes these attributes are so long. Here we have just, let's suppose, 15 attributes, 15 features. Sometimes these features can be in millions maybe, or even if I don't exaggerate it, like the problems that that you will be solving, that it will be having some features of, let's suppose, 100 features, and you want to see each of the feature, like you want to see what are the features on, you don't want to see the what is the data in there, you first want to understand what are the features. So there is a function known as columns, the basically attribute, it's not a function. So data.columns, if you want to see it, so I can just go to the coding window and show you how many columns. So actually by data.head you were able to see the whole data, but sometimes if you have 100 plus columns, it won't be able to fit on the screen. So what will happen is they'll just look smushy and they'll look in congestion. So it's better to print the columns separately to see what are the features, what are the features that I'm dealing with. So you can just call this data.columns. So data basically is the data that we read this data frame into, and then I'm calling the attribute columns. So you can see that here it shows the columns are sex, CP, uh, rest blood pressure, cholesterol, FBS, and the rest ECG, some things like that. Okay. So these are the features. That if you have hundreds of features, you'll have a list which contains 100 elements, and you will try to understand them. Now, if I want to, for example, understand what is this trust BSP, so I'll just copy it, and there will be information available. For example, I have opened something. So here, so here you can see that age means the person's age in years. Sex means if a person is a male or female. 1 means he's male and 0 means she's a female. Then CP means chest pain type. So there are different types of chest pain. Then T rest BP means the person's resting blood pressure. Then CHOL means the person's cholesterol level. So these are the features explained in here in with the data set. And if you want to do a thorough study, you can just read about the individual things to understand the data set better. Okay, I'm just showing it how basically you do machine learning in real time. You can also convert into numpy then. For example, if you just want these arrays, you want data to get converted into a numpy array, you can just have this function to numpy, data.toNumpy, basically it will convert it into numpy. So you can also see what are the different types. Let's again go to this. So you can convert into numpy. I showed you can just write to numpy, the whole data frame will get converted into the numpy array. So but sometimes what you want is, because you have different columns, if you see here you have different columns, everything is a numeric value. Sometimes you will have address column as well here. Sometimes you will have address column which will be a string. For example, if somebody lives in, let's suppose, new colony something, somebody lives in street number 4, something like this, so it's a mix of strings. So here you see that these are integers, these are float values, and these are object strings. So if you want to see कि कौन सा data किस column है, which type of data does this does each column contain, so for that we have a function d types. So if you see, we'll call this data.d types. So this attribute basically returns the data types for each column. सो हमारे पास एक कॉलम होगा, एक डेटा होगा, और हमें देखना है कि कौन कौन सा डेटा टाइप है हर एक कॉलम में. सो फॉर दैट वी हैव दिस एट्रीब्यूट, यू विल जस्ट कॉल डी टाइप. सो इफ यू सी नाउ the sex basically is integer, 64 CP is integer, 64 we see that old peak it's a floating point. So here we don't have strings, but if you had those it will show again object or something like that. So is this clear? Is this clear? Okay, so what I'm basically telling you is step one of machine learning. Step one of machine learning is that you need to read the data and you need to understand data well. अगर मुझे ही डेटा की अंडरस्टैंडिंग नहीं है, देन how am I expected to make a better model? So this is the step one, understanding of the data. Understanding the data. जब मुझे डेटा की अंडरस्टैंडिंग हो, then I'll be able to make better models. Sometimes this is called as interpretability. Interpretability means that I am able to understand data. There are machine learning models which you can use as a black box. You don't know data, maybe you'll feed the data and then you'll see machine learning will do something and it'll output the results. Okay, so but if you have the understanding data, maybe you'll have control over how model should perform, what are the things I should do. So all these features are being kept. If you see your recommendation algorithm, so what it takes basically, it'll again take your what is your sex, what is your age, what is the location that you live in, okay, what is the preference, maybe you prefer comedy and things like that. It will have a lot of data about you. So then it will recommend you the things. Okay, when it has data, then we'll feed that data into an algorithm called as recommendation system. Then that recommendation system will analyze the data and provide you the better recommendation. So this is basically data. We call it a digital profile. Okay, so digital profile means how you behave. Even I, like I have, we have so much data in for particular, for example, you are using a phone, your phone is collecting your data. It has your voice, it has everything, it has your locations, the places that you visited, it has all your preferences. If you, it basically is a philosophical debate. So what is a human? So human basically is nothing but a bunch of information. If you see, तुम लोग क्यों अभी ये पाइथन या अभी ये मशीन लर्निंग का कोर्स पढ़ने आ रहे हो? बेसिक थिंग इज, मे बी यू हैव सम इन्फॉर्मेशन इन योर हेड, एंड बिकॉज ऑफ दैट इन्फॉर्मेशन तुम्हें लग रहा है कि दिस विल बेनिफिट यू. ओके, बेसिकली द होल थिंग इज बाइस्ड. तो कोई कोई मशीन लर्निंग क्यों नहीं पढ़ने आता? दैट इज बिकॉज ऑफ द इन्फॉर्मेशन दैट हैव इन देयर हेड. सो एवरीथिंग डिपेंड्स द इन्फॉर्मेशन दैट यू हैव. सो इफ यू वांट टू कंट्रोल somebody, control their information. So what is basically information? It's basically education. Why are there Hindu nationalists and why are there Islamic extremists? The basic thing is they have some information in their head which is guarding them and which is sort of using them in that way. So यही मैं बोल रहा हूँ, the information that you are giving, and based on that information people will be able to take decisions and make other decisions based on that, and recommendation systems. I think everything that you are seeing nowadays is based on data. So for that we have to see the type of data we have. So for that I think we have, I told you that we have these d types. So it's clear. Is it clear? I can see people leaving and joining. Is my internet connection stable? Is everybody able to see the screen? Nice. So do you see why they call data is new oil? Now I think you must have an understanding data why is new oil, because your data is being fed into the machine learning algorithms to benefit profit. Basically, if you know a recommendation system for Netflix, the people who made it better, they were awarded $1 million. This is how much money is involved in the data. Okay, तो इसलिए हम लोग, because everything machine learning does is because of data. So data is new oil. So be really careful when you provide your phone numbers, when you give your names and stuff like that, because you can be targeted and there are targeted ads and things like that. There is a huge, and sometimes we'll discuss, maybe not on this recording session, and I'll tell you what are the things that we do with the data and how do we control masses with the data. कि जब election होता है को कि ये target ad करो इनको. We'll have a separate discussion on that. Okay. Then we have a function called as describe. Okay. So first thing is we have a function called as describe. So what describe does is, if I want at a glimpse, I want to see कि let's suppose कि average blood pressure कितना होता है एक patient का. Like I have these 297 patients. So average blood pressure कितना है एक patient का, I want to see that. And if I want to see कि maximum blood pressure किस बंदे का है, मतलब कौन सा blood pressure maximum है, कौन सा blood pressure minimum है, or some things like that, I want to see कि एवरेज मीन वैल्यू क्या है ब्लड प्रेशर का. आई वांट टू सी मैक्सिमम वैल्यू कौन सा है, मिन वैल्यू कौन सा है. आई हैव अ सिंपल फंक्शन डिस्क्राइब. आई विल कॉल दैट, एंड फॉर ईच कॉलम it will give me those stats. Let's go into the coding window and show you that. Okay, here we have that. So I'll just write this function df.describe. So what will it say? So here you can see that. I think I should write data because df is something else. I'll just write data here because my data is defined as data. So I'll describe it. So you can see that. Here you see that age, there are 220, sex, we have 297 people. So this count base will give me that. And then we have, for example, if you see this blood pressure. So average blood pressure is 131 for the patients we had. Then we have this minimum blood pressure is 94. And you can also see maximum blood pressure is 200. Are you able to see those stats? I'm just focusing on this blood pressure, but we have this data for each other columns. हमारे पास है हर कॉलम के लिए डेटा. यू जस्ट हैव टू कॉल दिस फंक्शन डिस्क्राइब. बिकॉज कभी कभी क्या होता है, हमारे पास डेटा आता है, देन यू से कि एवरेज ब्लड प्रेशर इतना होता है पेशेंट्स का. सो व्हाट बेसिकली दैट इज, दे हैव कलेक्टेड डेटा फॉर लेट्स सपोज 10,000 पीपल. सो उनके लिए एवरेज निकाल दे एंड दे से दैट एवरेज ब्लड प्रेशर इज लेट्स सपोज 120. Okay, 120 millimeters of mercury, that they call it. So we have this. So count basically means how many data points, how many records are there in that column. So we had 297 because we know that हमारे पास 297 patients थे. So what's the mean? Mean basically means average value. तो blood pressure का average value जो है 131, the patients that we have, because we have very less patients, only 297. Then standard deviation, we'll read it when we'll have maybe a lecture on stats and probability, and we'll see that what is the meaning of standard deviation. I think explain a bit in the NumPy wala session, but I'll explain it fully when we'll go into that statics wala portion. Then the minimum blood pressure is 94. Then they are called percentiles. 25 percentile. 25 percentile means uh, how many people, like above 25. Like this is the 25 percentile means people means that above 25%, these many number of people have this 120 blood pressure. Then we have 50th percentile. 50th percentile means half of this population has nearly 130 blood pressure. And then 75 percentile means like the last 25%, basically greater than 75. This they have this, and we'll also look at the concept of percentiles as well. Don't worry about these concepts as of now, because we have to read these concepts in statistics. These concept of percentiles, concept of standard deviation, variance, mean, correlations, covariance, and what are these things we'll read in the statics portion. But these are important concepts you want to see. And maximum value, I think you understand maximum value. Maximum value is the highest value that we have. Highest blood pressure is 200. So what is the function we have? This is describe function, if you see. So एक फंक्शन से हमें इतने सारी चीज़ें पता है, काउंट पता चल रहा है, मीन पता चल रहा है, स्टैंडर्ड डिविएशन पता चल रहा है, मिनिमम वैल्यूज एंड दिस परसेंटाइल्स एंड दिस मैक्सिमम वैल्यूज. आई होप दिस इज आल्सो क्लियर. इज इट क्लियर? So we are again to remind you, we are in the first step of machine learning, that is understanding the data. And how do we understand data? By first reading the data. And how do we read the data? By using pandas. Okay. Where is on which platform do we have pandas? That's Python, and we are using Python. So you can again transpose the data. I already explained you what is transpose, like converting rows into columns and columns into rows. I think in the NumPy, if you have seen that NumPy session, you might know what is a transpose. So here I want to change basically these columns into rows and rows into columns. You can just write data.t and it will just transpose the whole thing. Okay. Now we have functions as sort. For example, if you want to sort based on the index. So here the index, if you remember that, we change the index on the basis of age. So अब मैं ऐसा चाहता हूँ कि my data should be sorted. I want to sort my data. I want to, by sorting I mean there should be order in the data, and I want that order should be like first I should have the least age, and it should go in the ascending order, or we call it increasing order. So what I'll call is, I'll just call this data dot sort index. So based on the index, that's why this index is important. I told you like sometimes we have to set the index. उस index के based, let's suppose we'll sort the things. So we have a function sort index. So if you see this data, so if you see the original data that we had, so there were these things were in random. So you see that some people 40, 39, then 35, then again 35. So if you see the head of the data 69, 66, 65, there was no ordering if you see as such. So but if I want an order based on the age, I want an increasing order. You just call this function sort index. So based on that, now if you print this, so there now age is 29. This guy has the least age, then 34, 34, 35, 35, and things like that. It is basically this will be in the ascending order. Ascending order. I'm bad with the spellings. I don't write spellings fully. So just remember that we have the sort index. That's why you might have a confusion in your mind that ये sort ये index हमारे किस use आता है. This is one use case. कि if we want to sort based on an index, you can just call this function sort index, and your whole data will get sorted based on that index. Okay. Then if you want to sort each of the row, for example, you want to basically sort the row wise. अभी हमने sort किया था column wise using this index. If you want to have this axis and you want to sort this, so you can just write sort based on the index, but x is 1, and that too in ascending order. That this means you should have in descending order. So you have different arguments here. Ascending is false means now you should have in descending order as well. So if you see it here, you know that now we have a largest number in here. Okay, and now you have a largest number in here. Things like that. So I think sorting is clear to you, and there are a lot of functions of sorting. You can just read the documentation for howsoever functions. I'm just showing you the concepts. So again, to reiterate, my job here is not to make you memorize things. Like I really hate memorization. That's why I don't even memorize spellings. My job is not to do this memorization. My job here is to make you learn concepts, because I know that if you know a concept, this is again, if you just forget the name, this is just one Google search away. You can just write how to sort a data frame based on index. You don't need a function. You can just write that, and after that, Google will give you there is a function sort index. And if you want to read about it, you can just open the documentation. If I want to show you that also, I want to show, because I want you to be really good skilled in every domain. So for example, I'm opening and I don't know how to sort things. So how what will you do? But you know that sorting does exist. So you'll just write how to sort let's suppose data frame based on index, based on one column, let's suppose. So you can directly see here we have this Stack Overflow. You can go on Stack Overflow and read that. My internet is a bit slow. So here you can have a long answers in here, and then you'll read this. This is how basically people will get the hang of these things. I don't want to memorize you, and basically when you'll become senior coders, you'll easily be able to remember all of those stuff on your own. Okay, you can also sort by values. By values, I mean if based on one column you want to sort that. I just search that, and you can see that here we have a function sort values, and then we write this by cholesterol levels. Okay, so if you see that here we have cholesterol levels in ascending order. So 126 is the least, then 564 is the highest. So we sorted all of this data into by using this cholesterol column. Is this clear? Is the sorting clear? यार मैं बहुत अच्छा पढ़ा रहा हूँ, तुम्हें सब समझ आ रहा है, otherwise you are all sleeping because I don't I'm not getting any questions. Zubair, are you there? हाँ, Zubair is there. Nice. So are you understanding the things? I also want to take opinion of Rian. So Rian actually had an experience with this data cleaning, so he thought this is a boring job. Do you now feel it's a boring job? Rian, are you there? I think there is some issue with the microphone, or maybe. So how many of you feel that data science is an interesting job now? Now you can do it for life. Only one of you, maybe two, three, four. Nice. I think most of you are now do agree that data science is a good job because it gives so much insights. Just remember this: data is new oil. Okay, so this is new oil. Based on the data I have about you, maybe I can predict your future as well. So based on how much interest you are giving in these lectures, I am building also a recommendation system. So which will tell you, like maybe we'll have a discussion on some other day. So I just want to get you like ingrain this thought that data is new. If you have data in your hand and if you know enough information about somebody, so maybe you can do wonders with the data. So there is a quote also: keep your friends close and enemies closer. That means basically have more data about your enemies. So if you want to wage any war, if you want to learn things, if you want to achieve anything, so have more information. That's why they call education is power. I think it should be reframed. Data is power now. Okay, then we have selection. Okay, अभी हमने सीख लिया कि sort कैसे करते हैं data frame को. Now we also know how to read the data frame. So we know a lot of stuff. So now I sometimes want to select a particular column. I sometimes want to select a particular data point. I sometimes want to analyze only one thing at a time. So if you see you have a whole dictionary, but in the dictionary you sometimes want to just search for one word. You sometimes want to just see कि मुझे एक word में देखना है या मुझे एक story पढ़नी है इस book से. So for that you have to select the things. Okay. So जैसे हमने देखा कि there are slicing, there is indexing that we have been seeing in previous sessions. So that also apply in here. So but we have other functions like data frame IAdd, data frame location, data frame ilog. And these are advised to use. Why? Because the access is faster. Okay, Pandas makes it the access faster because I told you most of these codes is written in they have C base and C is really faster. For example, if I want out of this data, I just want to analyze, let's suppose this cholesterol levels. So what I'll write is there's a simple syntax I'll write. I'll write data. Okay, then I'll write this cholesterol level. So it'll give me one column. I'm basically selecting one column. Okay, let's go into the coding window and show you that. Sorting, I think this is clear. For example, here I want to see the cholesterol. Okay, if I want to analyze कि age के साथ cholesterol का क्या relation है, is there a relation between, because now my age is index always will get printed, so I want to see cholesterol, so I'll just write data because I have the data frame with me, then I'll write this cholesterol. So if you can see that, you can see that higher the age, for example, for the 69 people, he has 32, 34 cholesterol level. So if you see this 35, they have, let's suppose, 183. Again, some there is this is called an outlier. So the guy is aged 35 and he has cholesterol level of 282. This may be he may be in the obese category. So this is also, there are something called outliers. By outliers I mean कि जो normal trend में set नहीं होता. Usually people who are aged between, let's suppose, 18 to 30, they are really I'll say energetic and powerful. And but there are some people who are really fat and they cannot run, and they cannot. These people we call them outliers. So here you can see that 35 is an outlier here in the last data point. But you usually see that higher the age, the cholesterol level is a little bit higher. If you see 65, 282, 64, 211. So 35, 198, 35, 183, something like that. Because here I want just study about the cholesterol, how how age impacts the cholesterol level. Okay, you can also equivalently just call data dot cholesterol. You don't need to write this cholesterol. You can just call data dot chol. Again, the same thing will get printed if you see. Okay, here the same thing got printed, here the same. You can just now you have two methods if you want to access one column. Here we are now trying to access one column, selecting one column. So we can write that column name, or we can just write dot that column. Is this clear? Is this clear? How can you access one column of the data? Nice. I only got thumbs up from Umar. Nice. Everybody. If I want to slice the data, for example, by slicing, you know this. You by now you must have by heart the slicing. So you have this data, and if you want to have the first, for example, 0 to 7 data points, so I can write data 0 is to 7. You can slice one other thing, you can slice the rows. This is the slicing of rows. If you want, for example, data points 8 to, let's suppose, 15, so you can just slice it. Okay, so here these are the points from 8 to 15 if you want to take a bunch of people. Okay, this is called basically the slicing. We have read it in lists, we have written in numpy arrays. Again, we are coming to slicing in this pandas data frame. Then we have selection by label. Okay, then there is a concept of selection by label. Let's go back to our tab screen. So till now we have been taking a whole column. So now what I want is, I want to select based on the label. It should be label. It is the wrong spelling. It should be label. I correct it. So there is a method called as dot loc. Basically, this means dot location. Okay. So how it works is, you can give a row label, comma column label. Okay, or you can give a row slice or a column slice. I'll tell you briefly what that is. For example, I want to know that I want to take the people who have 66 age, and I want to know their cholesterol levels. Okay, जो लोग 66 एज के हैं, I want to check their cholesterol level. So what I can write is, I can just write data dot, because this is selection based on labels. So I'll say the people, because index now is 66. I'll just write 66. It means age is 66, and I want to check their cholesterol level. I'll write cholesterol. This data frame will return me the people who are having the age of 66, and tell me their cholesterol levels. And sometimes, because we want to see this, is age category mein cholesterol level kitna, and maybe I'll find mean of these and things like that. Okay, going back to the coding window, and to show you, you can just use this data dot location. 66 means the age, because this is the index. If I do not mention it, this is basically the index. Then I want to see the cholesterol level. Here you can see that all the people who have age 66 were returned to me with their cholesterol levels. This is one method, and then we can again use slicing and selecting a specific column. Is this clear? Is this one clear? This example. How can you just use the labels? Basically, how can you select based on the labels? Now I want to use slice. I want to slice some rows and select specific columns. So what I mean by that is, so if I have this dot location, and the indexing works like this. This is row slice. Remember this. This also works in NumPy. This also works in lists. This also works in your matrices in C++. I think it works everywhere. And then is to, then we have column slice. Okay. So let's suppose this is our matrix list, whatever we want to call it. So let's 0, 1, 2, 3. Let's have some more columns. 0, 1, 2, 3, 3, 4, 5, 6, 7. Okay. So what I'm showing you here is, so let's suppose if I write like this, if I write 0, okay, then I'll write, let's suppose is to, it should be comma, sorry. So I write 0 is to 7. So it will select, not even 7, I'll write 0 is to 2. So it will select these many rows, 0 and 1, and exclude, it will select first two rows because this is the row slice. So this will select these two rows. If I want to color it, this will slice, select these two, and then column slice. If I put comma in here, then if I write 2 is to 4, let's suppose 2 is to 5. So it will select this much here. Let's suppose 2 to 4. So basically the selection will happen like this. So this will be the selected portion. Is this indexing clear? I'm not going to the locate. Here I am showing you, this means this is a row slice, and here this means this is a column slice. So sometimes you want to select a subset of the things. So for that you will write a row slice followed by a column slice. Okay. Now here if you see that, again showing you the example here. So if I write data dot log basically means location by using the labels. Then here I'll take all the rows, all rows. Because I told you that by default if I just write this much, it will take all the rows. Is Sharika here? She was in the previous session. Is she here? Okay. So you were previously active in the session, so you must remember this. So there are default values here. So if I do not write anything, it will take all the rows. And then I am giving a list of columns. So this basically is a column slice. So what should get printed is all the rows, but only two columns, CP and this old peak. So if you see it, you can check it here. So here we got 297 rows multiplied 2 columns. But if I want less columns should get printed, I'll write that range over here. If I go back to the coding window and I'll show you there. If I want to select, let's suppose 5 to 8 or maybe 5 to 15, you can check here. Only these many rows got selected. But if I do not write this start index and end index, so what will happen is everything will be selected, but only these two columns. If I also want to, let's suppose cholesterol levels in here, I also want cholesterol levels. Now 3 columns will get selected, all the rows will get selected. If you see it here, so here we have these. But if you only want to select, let's suppose few columns, you want to select 16 to 23. Now you can check that. Oh, sorry. Something is wrong. That's why I don't like to test the code because it will give surprises sometimes. Let's go with this. I probably missed this comma, I think. So it was 16 and suppose 23. So you can now, oh, it is showing some exception, maybe on based on the axis or something like that. Maybe there is nothing from 16 to 23 because we have indexed or randomly indexed based on the age. Sorry, So I hope now this got clear that you can select the column slice and you can select the row slice basically. Let me. I'm not able to. It's okay though. Let's move. These are huge errors you can see. Is it clear now? Is this clear, like column slice and this row slice based on this separated by these commas? I hope this is clear. Let's again go to this. So what I want to show is sometimes want to select a single row. I want to select a single row and a column label, for example. Suppose, for example, if I want to select the first row, because now my data is indexed based on this 0, 1, 2, 3, and I want to select this, and I want to select what is the old peak for the first index. Let's suppose for this person. So what is the old peak? So I can just write it like this: data dot location and the first index and write its name. This is how we access a single row and a column label. It returns a scalar. I also explained what is a scalar in the NumPy session. Scalar basically means one value. There are multiple values. This and this thing is equivalent. So if you see this data.log 1.old peak, you can also write this data.at and then write this 1 comma old peak. They basically will return the similar results. Okay, but this is faster. Okay, and they're equivalent. So why is it faster? I think I somehow explained it in NumPy because they don't create temporary arrays, and it basically depends how are they implemented behind the scenes. So it is better to use this at method. Okay, if you just want to access one scalar element, if you want to just access one element. Okay, so what we saw how to access a column. Then we saw how to use a slicing method as well. Then we'll see how to select by position. Sometimes you don't want to remember names, किसी को remember नाम नहीं पता attributes के. So the thing is, what you can do, if I want to access the third data point, मेरे पास data point है, and if you see that data, if you see this data, it's in here. So if I want to, for example, see some point, let's suppose this point, this I want to only select this point. Okay, as it's not named, so what I can do is I'll call I location. The first was based on the labels. Now here we have, there is loc dot loc and dot I location. Remember these, there are two functions. So this selects based on labels. Okay, so where is that? This is the I, and this selects by the position. So these are two methods of selecting. So we saw how to select one column and how to select based on the names or the attributes and things like that. Now we'll see how to select based on the position. Let's suppose from this data I want to see the fourth patient's data. I'll just call this data.iloc of 3. Let's go back to the coding window to show you that. Okay, let's suppose I'll take the fourth patient now. Fifth patient, let's suppose. So you can see that the fifth patient, he's a male. There's a missing value, maybe CP, it is 0.0, it was not given. Then we have blood pressure level 1110, then we have cholesterol 211. So this is the whole data about the patient, let's suppose patient 5, because we index it from 0 to 4. So it's the patient 5th has this data. So we have just used iloc. If I use location, then there will be a problem. So iloc is used for selecting the data based on their position. Now again, the similar way you can use iloc with the row slice and the column slice. Okay, so here for example 3:5 means select the rows 3 and 4 and select the columns 0, 1, 0 and 1. If I can just, because I know here we have more columns, I can select maybe 3 to 10, and then I can select 0 to, let's suppose 4. If you can see, now we have how many points we have. This is our row slice, so we'll have 3 to 10 rows. That means basically we'll have 7 rows, and then we'll have how many columns? 0 to 4, that will have 4 columns. So you can see that first 4 columns, sex, CP, rest, blood pressure and cholesterol are there, and this is our data. We are basically subsetting it. Is the iloc clear so far? Okay, then iloc can also be used with a list of integers. For example, I want the first data point, second data point, fourth data point, and I want their columns 0 and 2. So you can just create two lists. So this list basically tells which rows to take, and this list tells which column to take. Okay, so going back here, so I can clearly show it in here. So here this is for the rows and this is for the columns. If you want to see, I want first, second and fourth patient, and I want to see their 0th feature and the second feature. So you can just call this function. Here we have 3 patients and I want to check their CP, the chest pain type. Basically chest pain type is 000 for all of these. And again for the slicing, like I think you must be an expert in slicing by now. So this is slicing rows explicitly. If I want to take all the columns, just some rows, you can do this. If I want to just take all the rows and some columns, you can do this. Okay, you can just take one element only. So you can just like iloc 1 that means take the first data points, first feature. So if you have a whole table, so out of the table you want to just select one cell. Let's suppose this is 0 1 2 3 0 1 2 3 based on the indexing. So I just want this 1 1, so this cell. So I can just call iloc 1 1. So better for fast access, you can say data I at 1 1. So both of these will give you the same results, but this is faster. Okay, is it clear? Is it clear? There is still time left. I want to finish it. And then we have something called as Boolean indexing. Okay, what I mean by Boolean indexing is like this. So for example, I want to see all the people who have blood cholesterol level, basically high blood pressure. But I told you high blood pressure basically means above 140, greater than 140. I want to select all the patients who have blood cholesterol level, this blood pressure level greater than 140. So how I can index is, it's like this. I'll write data, then for the data of that column, this is the column, it has greater values than 140. So if I go to the coding window to explain it, so that you get the better hang of it. So here we have, so this is our data. If you see, this is our data. So here I only want to select the people who have high blood pressure. So that's what I can do is I'll write data. This data basically means the data frame that we have. This is the data, and then I'll select the data resting blood pressure, which is greater than 140. I'll write this greater than 140. If I now run this cell, you can see that all the people who have greater than the blood pressure greater than 140 will be printed here. And if you see this blood pressure column, so there will be no patient who has blood pressure less than or equal to 140. There are all people have greater than 140. So how many people are there? There are 66. It also showed you 66 multiplied by 13. So 66 people out of these 297 have high blood pressure. So this is called as Boolean indexing. Why? Because this will return true or false for certain things. So for the patients which have blood pressure greater than 140, it will return true for them, and for other people it will return false for them. So this is called Boolean indexing. So you can set a certain condition कि अगर इस feature में मुझे ये condition चाहिए, then you can call it like this. You can select based on this Boolean indexing as well. Again, for example, you want to see कि कितने चीज़ें हैं जिनका value greater than 0 है. You can also see data greater than 0. Is it clear? So हम कहाँ पे हैं अभी selection पे, how to select these data, we are seeing the different methods of selection. So I don't want to lose the big picture. We call that, we are doing now what's called as micro study. तो macro study is कोई बंदा ऊपर से देख रहा है चीज़ों को, ये steps होते हैं. Now we are doing micro study. अगर हम data को understand कर रहे हैं तो data understand में टाइप उस टाइम पे हम लोग को पहले तो data को देखना पड़ेगा. You have to understand features. You have to now select features. You have to do certain things on the data, and after that you will be doing machine learning. This step is called pre-processing of data. Pre-processing. You will learn a lot of pre-processing. The first stage in pre-processing, again, now we are unboxing it. I told you, like, there is a whole pipeline, there is a whole workflow we'll go through. We'll learn a language, then we'll learn some libraries, then probably we'll learn some databases, then we'll learn some maths and probability and some stats and things like that. Then we'll go into ML algorithms, and then we'll go into deep learning algorithms and make some projects, some things like that. So what we did is, now we're taking these libraries and we are sort of unboxing it. What is in there? So in the unboxing, we are first taking pandas and going to the deep study, going to the micro study. Micro study. So अगर कोई बंदा कोई garden देखने जाता है, the first thing is we see a bird's eye view, बाहर से देखते garden कितना बड़ा है. Then if you want to go into the, that's called macro study. बाहर से देखना. What is micro study? You will go on to those plants and see the flowers there, and you'll see some water streams coming out, and then probably you'll see some huge trees. So that's micro study. We are right now in the micro study phase. We are micro studying these pandas. So I hope that you also understood what is that this boolean selecting or boolean indexing we call it. So now let's now go how to create a copy. For example, if you want to create this copy of the same data, you can just write data1 data.copy. So this is deep copy. There's a concept of cow. You know what is cow? Copy and write. Copy on write. Python में हर एक जानवर है. Python, cow, even I think we have ox as well. So cow basically means copy and write. I'll teach you somewhere like copy and write क्या होता है. Again, I don't want to digress कि copy and write क्या होता है. So here we are creating a deep copy. So I also explained you in the NumPy session what is the difference between a view and a copy. View basically means it's the same object and you are getting a view of that thing. Deep copy basically means it's a new file, new object, and it is not the copy. It's not the view of the same file. So if I just write data 1 is equal data, so it will create what is called a shallow copy. Shallow copy. Shallow copy means if you happen to change this data 1 will basically data has some file. So there is a file, this data is pointing to it. So now if I write data 1 is equal data, so again a new pointer will be created towards this file which will be data 1. This is called a shallow copy, or it's not copying at all basically. Copying basically means you have a new file, you don't have. In order to create a deep copy, in order to create a new copy, you must write this method copy. So what will happen is, when you write this copy, because you have this data, so this is our data, so it was pointed by this data. So now if I write this line, data1 data.copy, so what will happen is, it will create exact copy of this, same copy of this will be created. Now data1 will be pointing towards this. Actually this a new copy got created if you see it here. So in this a new copy got created. Now these they do not only share, they do not share the memory basically, they have their separate copies of the files. So for deep copy you must create this copy method. So I hope the people who have seen the NumPy session, they know a difference between what is the difference between view and the copy. Okay. Now what I'm seeing is I want to use, there is a method called isIn method. So for that I first create the copy of the data. Okay, then what I did is I added one more column. So how to add one more column is, if you know list comprehension, I taught you list comprehension. So I'm creating a list. Okay, this is creation of the list. That's why you must revise think this list comprehension. I'm basically creating numbers from 0 to 296. Basically 297 points I'm creating in this list. And then I'm assigning this list to data 1 of data. What will happen because of this? It will create a new column. If you see in here, it created a new column in this data 1. I wrote data 1, then of data is equal, I create a new column data because we didn't have that. And then what are the numbers? I assigned this list into that. So list is 0 to 296 if you see that. Is this code line clear? What I did by these two lines of code? Sometimes it's easy to write and difficult to understand the code. Have you understood these two lines of the code? Zubair, are you there? Nice. So have you understood these two lines of code? What is the meaning of deep copy, shallow copy, view, or maybe a copy? And then again, to reiterate, I am just adding one more column in here because I want to show you the functionality of this method is in method. So this is also used for filtering. So now I have this additional column which I added in there. So you also learned how to add a column in the data frame. So what I want to see is I want to take only these data points which have some specific values. For example, I want to take the data points which have the values 0 and 1, or maybe 1 and 2, whatever I have written in here. So what I'll write is I'll write data 1, data of this dot is in. So in a particular column, I want to check if there is 1, 2 for some data point. So what will this return? This return only those data points for which this column has values 1 and 2. So here you can see that only these 2 points have values 1 and 2. These two things got returned. So if I want to check if I have a certain column और उस column में कुछ particular values है, मैं देखना चाहता हूँ वो किन किन के पास है. For example, if I have a huge record of patients and I want to check the names कि किस किस का blood pressure level इतना इतना है. For example, I want to check the blood pressure level is 100 and 200. I want to filter out those patients. So what I'll write is I'll write this is in method. Just see the syntax. First I am writing the data, whatever data we have, then I am writing these braces, then data 1 again, basically writing the column that I have just added data, and then I am saying is in कौन सा वो पेशेंट है जिसके डेटा कॉलम में वन और टू वैल्यू वन या टू वैल्यू है. सो इट विल जस्ट रिटर्न दीज टू थिंग्स. इट विल जस्ट रिटर्न दीज टू कॉलम्स. ओके, इज इट क्लियर कि इज इन मेथड क्या करता है? इज इन इट विल टेक और आर्गुमेंट्स की कौन सा एक कॉलम है जिसमें हम लोग पर्टिकुलर वैल्यूज चेक करना है, वो किन डेटा पॉइंट्स के लिए है. सो वी कैन रिटर्न देम, वी कैन डू सम मैनिपुलेशंस विद दीज थिंग्स. Again, here I am adding a new column of data called new data. So data basically, this is basically similar what I did previously. So now I can also set values. So here now I am done with the selection wala part ki how to select values. Now what I want to do is I want to set new values, setting values. Sometimes I want to set my own values. For example, अगर मुझे चाहिए कि मैं इस कोलेस्ट्रॉल लेवल को बदल दूं, मुझे 174 को चेंज करना है. For example, due to mistyping, there was human error and people typed, but I want to manually set those values. So there are methods as well in Pandas by which you can set values. So for example, you can write data at zero and rest blood pressure. So you can write 50. So what will happen if you see this 0 and this value is 160. If I want to set it to 50, so what I can do is I can just call it like this: data dot add, then 0, then is equal to 50. So if I now print the head, you can clearly see I changed it to 50. Is it clear? By using this add, how can I change the value? How can I set the value? Are you sleeping? Other people, are you sleeping? No, you're not. Nice. So this is add, and as we had loc and iloc, so we have at and I at. Basically, this at is directly taking a label. As you saw that it took a label. This I at, it takes index. Okay, similar thing can be done by index. For example, I at basically means 0 and 1. 0 1 means take this 0 and the first value CP. This is 0. Sorry, this is 1. So take this value and change it. So we are what we're doing is we're writing I at in here and change it to 45. So then you can see that 45 it got changed. So this is how we set values. Okay, we can also set values by using this location and assigning. For example, you want to see data.1 location and take the sex column So this will select all rows, as you saw that. Then this will only take sex column, and what will happen is it will multiply by 5 and length of d, whatever the length was, and it will multiply that by 5 if you see that. So here we have, this is 5 5, everything we overwritten this 5 5 5 5, sex value got changed to 5 5 5. Okay, this 5, if you write this 5 multiplied by something, let's suppose 10, so it will create a list of 10 fives. That's what the syntax means. That's the meaning of this syntax. So if you have a list 5, if you multiply it by 10, so what will happen is it will create 5 comma 5 comma 5 10 times. So here we have length of df basically means 296, so it got multiplied by 296, so multiplied by this 5, so it created a list of 296 fives. So I want to assign that to the 6, so this is what happened here. Is this clear? Is this clear? What is the meaning of this? Pay keen attention because these are small nitty-gritty details, and when you will be doing your projects, I think that time you will sort of assume it. Okay, इससे ये काम होता है, इससे ये काम होता है. Okay, I'm just showing you how to set values and how to set by assigning. So when I'm creating a numpy, first I'm creating a list, then I'm changing it to numpy array. So people who have studied numpy, they know this is how I change a list into a numpy array. So this is a list basically, then I'm creating a numpy array out of that list, then I'm assigning that to a whole column. So this value is getting into this column. This is how I set. Now we are done with setting. We know how to filter values, we know how to select values, we know how to read files, we know how to create data frames. We learned a lot of stuff. Okay. Now there are also sometimes common represent values. For example, missing values are there. I think I told you what missing values. Sometimes we don't have a value for a particular thing. So missing values are represents as NaN. That is not a number. So you have to deal with missing data as well. Sometimes the data is not having all the proper values, so you have to deal with the missing values. What Pandas does, it provides you the missing values. It provides you basically the tools to deal with these missing values. How to identify these missing values? There is a function called isNull. IsNull basically says if a value is missing. So in our case, there is no value missing in our data set that we loaded. So let's create a data set which has missing values. So if you see in here, I'll just create a data set. I think I have created it somewhere. So yes, I'm creating it. For example, here I'm making a dictionary A, then I'm giving a value 1 np.nan means I'm not adding a value, then 3. So if you just check this data frame, I'm just commenting out these lines for now. So if you just print this df, this is how df looks like. It looks like there are two features A and B, then there are 3 data points, and there are some not number values, basically missing values. So this happens in real world because there are missing values. When you collect data, there are missing values due to human error or due to equipment error, howsoever you're collecting the data. So there is this not an error. And if I want to check if we have a huge file, let's suppose millions of data points are there, it has thousands of features. I want to see how many things are having this not a number value. So I can just call this function print df is null. So what will happen is it will show false, true, true, something like this. So it will show false for the points where they have some value and true for the values which are not a number. Okay, is it clear? How do we detect not a number? How do we detect like there is a missing value? You just call this function is null. Now I want to deal with this value क्योंकि मुझे machine learning model को train करना. For that I must have these values. I must have, otherwise my machine learning model will perform poorly. क्योंकि उसमें data ही नहीं है because I have missing values. So for that I have to deal with the first function that I'll discuss, which pandas provide, is drop NA. That means drop these numbers. Okay, drop these rows which has these not number because I don't want to take these data points because otherwise I'll create a faulty model. So पहला जो method है वो ये है कि इनको drop ही कर दो, इन rows को drop कर दो. So if you see that we have only one row, the 0th row, where we do not have where we don't have this not a number. For other two we have this not a number. If you see, I can again show it. So here for the first and this second indexed rows we have this not number. For the first method is drop them. I'll just call this drop NA. If I call this, you can see that only now the row left is only 0th row. Okay, and the second value is second function by which we deal with these missing values is called fill NA. Fill NA with a particular value. Basically this means that if you have a not a number value, fill that with a particular value. Let's suppose I'll fill those numbers with 5. So as you know that not a number exists in index 1 and index 2. If I run this function, you will see that now wherever the not number was there, it got filled with 5.0, it got filled with 5.0. Let's suppose we'll have 10 here. So you can see that these two were not a number values, this 1a and 2b. So they got filled with 10 values. Now we have at least some value. And there are other methods like interpolate. So they have methods like interpolate in which we use linear quadratic methods and stuff like that. So I just hope that you got how to deal with missing value. There are two methods which I just discussed: drop NA, fill NA. There is something called interpolate. Then there is replace as well. There are a lot of methods. You can just read the documentation for these things. So the concept that I want you to get hang of is that in the real world data there are missing values. Okay, there are missing values, and you have to deal with the missing values. Because if you have missing values in data, the model that will be creating, probably a machine learning deep learning model, it won't be good. And sometimes machine learning model really they perform poorly on this missing data. So we call it missing value. If you remember our first lecture, I think it was our first lecture, lecture 0 is orientation, lecture first. I told you that there are models specially made for these handling these missing values. How many of you remember that? Nobody. I told when I was talking about the tasks. So I told you there is supervised learning, unsupervised learning, there is a classification, something like that. I also told you that we have models which work on these missing values. So this is what I was talking about that time. So in the data we had missing values. So when this is a suggestion to all of you. So whenever you will watch this entire course, because here I'll have bits and pieces together. So I'll first explain you some things, and you will not fully understand that thing there. So I'll urge you to just repeat these lectures and once again go through it. It won't take like more than half the time that you took to watch these lectures, because what will happen there that time is you will be easily able to understand the full detail now, because we have discussed these concepts in the first lecture. You are not able to understand what is data. Now you know what data is. If you see that lecture again, it will make more sense to you now. Okay, this is what he means by data, this is what he means by having missing values, this is what he means by classification. So having this background now, you can rewatch the lectures. Okay, so I discussed this drop NA, I discussed this fill NA. So there are methods like interpolate. So it also takes arguments like linear, quadratic, and there are methods like replace. So all the values, all these methods, they are basically there to handle missing data, handling the missing values basically. I hope that this is also clear. Now I think this is our last topic. So we'll then wrap up the discussion of pandas. I'm just scratching the surface of pandas. If there are separate courses on pandas. Okay, there are separate courses. I don't think people teach in that depth, but there is documentation available. I just want you to know what you can achieve with Pandas. So there's a documentation, I think python.org. So no, I think pandas.org. So you can go there and read in detail about what are the capabilities of Pandas, because there's a huge library. So I wanted to just cover up these libraries in one session, so that to give a flavor what are the things that we do with these libraries. So I think this is the last topic for the day. Operations. What are the things that the operations that we can do? The first operation is mean. I can calculate the average for a particular column, let's suppose, and I can calculate the median, standard deviation, variation. So this variance, sorry. So variance. So all these statistical properties, I told you that I'll be going into detail. What is the meaning of variance? What is the meaning of standard deviation? And what is the use in data? So these things we will have when we will read about stats. But remember that there are functions by which we can compute these. For example, if I want to create if I want to see mean of the data, for example, what is the average age? So average age is 54 that we have. What is this blood cholesterol level? Let's suppose cholesterol level, average cholesterol level is 2. I just call this data one dot mean function. So there are functions like median, standard deviation, variation, and variance, and things like that. You can call these functions to get these particular values. Similarly, you can get the mean around a particular axis. Axis 1 means basically the horizontal one, if I'm not wrong. Huh? Yes. So you can get these values as well. For example, axis 0 means the vertical axis. I also discussed the same thing in NumPy. So you must watch this NumPy. You saw that how there is a dependency of these things within each other. So axis 1 is the horizontal axis. You can also create this mean, variance, and standard deviation along the horizontal axis. By horizontal I mean sometimes you want to average the things on the columns, and you want to find the average of here, average. And sometimes you want to find the average of a row. So you can just write this axis is equal to 1. There are other methods like summation, find minimum value, find maximum value, and find the count value and how many things are there. So for that there are specific functions. You can write this dot sum, dot min, dot max, dot count. I'm not going into detail because in the assignment you will be heavily using these things. We'll be giving a separate assignment on NumPy. We'll be giving a separate assignment on pandas, so that all of these things will be revised. Then you can also have user defined functions in Python, so in pandas. So for example, if I want to find the mean, and for that mean I want to multiply it with 5.6. Okay, so what I can write is I can just write df dot aggregate. By aggregate I mean I am writing my own function, then I'm writing this lambda function. That's why this understanding the lambda function is also important. So what will happen is it will give each of this data point and then find its mean. Then we have transform again as well. So if you want to apply some transformation in the data, okay, so same thing, you can transform the data, whole of the data. So by using these lambda functions again. I hope this is clear. You can just pass the data frame and then write a function. It will take each the value and multiply it the value with 101. So here if you see that I have these values, I multiplied this data frame with 101. So here you can see that. And these functions do not apply, they do not apply on nan. As you can see the nan remained nan. Nothing happened there when I even applied these transformations. So when to transform data, so we'll learn the transformation like min max scalar and normalization and things like that. I'm just throwing you the terms because I want you to know that these things we'll use in the future. How to transform whole the data, how to use this aggregation method and things like that. Okay, and then there is a beautiful thing, value count. So if you want to count a particular value, let's suppose we'll create a series, pd series and p dot random, and we'll create some random numbers, some 10 random numbers we are creating. So now if I want to see the count, for example मैंने number create किया 5 6 2 0 3 0 2 0 6 6 something like this. So I want to see कि इसमें कितने 6 है, इसमें कितने 5s है, इसमें कितने zeros है. So I have a function value counts. If you see that, I'll just write s dot value counts. It will tell me 6 3 बार आया, okay, 0 3 बार आया, 2 2 बार आया, 5 1 बार आया, 3 1 बार आया. I'm basically counting these values. If some value is repeated and I want to see ये कितनी बार आया है इसमें, so I can write this value counts. Is it clear? Is the value counts function clear? Okay. Then pandas also gives us ability to manipulate strings as well. So there are methods specifically for the strings. If I create a series of this apple, banana and grapes, so you can see that I create the series apple. If you see that this is the series apple, banana and strings, and if I want to convert all these strings into uppercase, I'll just write str dot upper. If you see that, it converted to apple, banana, grapes. If you see this, if I again want to convert into lower, I can write str dot lower. So here we wrote that. So again we can get length of the string. So I'll just write s dot st. S means this is the series that we created. Then str is the function. Str is the module where we have these methods, and then we'll call dot length. It will say that string 0 is of length 5, string 1 is of length 6, string 2 is of length 5. So you can see that in here. So these are the specific methods that pandas gives us for strings. So you can replace some characters. So I am saying replace a with x. So for example, we had apple, we had banana, then we had what we had? We had grape. So what I'm saying is this replace method, what it does is it will replace a with the x's. So here this will be replaced with x, this will be replaced with x, so this will be replaced with x. If you see the output, you can see the a is got replaced with x. There's the replace method as well. So string contains also, like contains I mean that it is having that substring, if you remember the concept. So it will just return the boolean. So for example, str string contains p. If the contains p, it will return true. Otherwise, it will return false. Again, we have functions like starts with, ends with. Oh, there are a lot of functions. So what is the takeaway of this? That pandas, it provide some explicit functions to deal with strings. To deal with strings. सो पैंडाज हमारे पास ये चीज़ें भी देती है कि हम लोग स्ट्रिंग्स को अलग से हम लोग हैंडल कर पाए. सो देयर आर लॉट ऑफ मेथड. देयर इज अ स्प्लिट मेथड एज वेल. इफ यू वांट टू स्प्लिट a string based on some character, for example we want to split based on this a, so you can see that based on this a we got nothing, then we got pple, then we got b n, and then we got list splitted. So there are a lot of methods. I think there will be greater than 100, or I'll say like 500 functions only based on strings, which are like built in which are built in the pandas. There is a lot of things again to cover, I think. Okay, I think we can call the session off right now because I'll cover these things in detail, because now this is an important concept, how to join these two tables and stuff like that. It'll hardly take us 10 to 15 minutes in the next session to just cover these remaining concept of concatenation and stuff like that with the data frames, and we'll be done with pandas. And in the next session we'll be seeing matplotlib. This is a plotting library by which you will plot the data. So if you have data, you want to plot it, and there are a lot of graphs and a lot of histograms available in there. So was Pandas session good? Like, do you learn something? If you have any questions, you can ask them right now, or you can discuss with your fellow mates, and you can even ask the questions in the group as well, so that it benefits the broader audience. And if there is no question, I think we overshot the time. Are there some questions? No. We'll have a session. The people who are facing some errors, उनका एक session रखते हैं. I'll stop this recording so that we can have an informal chat. मैं इसको record को stop